Okay, so page 11 in your notes. We're going to talk about the triangle proportionality theorem. Triangle proportionality theorem. If we have a line that is parallel to one side of a triangle, and that line inside the triangle intersects the other two sides, then it divides the sides into segments of proportional lengths. Remember, this word proportional means we're going to write fractions. So when we have segments of proportional lengths from the sides, that means we will write fractions from the sides. Specifically from the cut sides. Sorry, let me add that. From the cut sides. All right, so to take all of those words and make it make sense with how we would use this in a problem, let's look at example number 1. On example number 1, do you guys see these little arrows here? That's what tells me they're parallel. So I have a line inside the triangle that is parallel to this big side of the triangle. So far, so good? So I'm going to look at this line that's inside the triangle, and where it hits the two other sides, the two other walls of the triangle. And I'm going to look at this piece and this piece. It's taking the side of the triangle and it's splitting it into two parts, into a part that's 6 and a part that's 10, right? And then over on this other side, my parallel line comes over, it hits this side, so I look at this segment and this segment. If I know all 4 of those little segments, then I can set them up as fractions. We're going to make a fraction out of these two. So I'll make a fraction out of the 6 and the 10. So I would have 6 over 10 equals, and then I'll do the same thing over here. I'll make a fraction out of these two, out of the x and the 12. I have to make sure to match up the corresponding pieces. 10 and 12 are corresponding here. Since the 10 went in my denominator here, the 12 has to go in the denominator of my other fraction. So I would have x over 12. So far, so good? All right. Let's solve this for x. How many x's are in my equation? Just one. Awesome. Since it is only in one equation, and is it on the top or on the bottom? It's on the top. Let's look just at this fraction right here, and let's undo this fraction first. How do we undo fractions? Multiplication. What part of the fraction do you multiply by? We multiply by the denominator. So what are we going to multiply both sides by? 12. If you do it to one side, you have to do it to the other side. It's going to cancel out my denominator over here on the right. The 12 only multiplies to my numerator of 6. What is 12 times 6? 72? No, that's okay. Yep, I did the wrong thing earlier today, and I was like, oops. So I have 72 over 10 equals x. Is x all by itself? Yes. So then the other side of the equation, I'm just going to put into my calculator and simplify. I need to do 72 divided by 10, which gives us what? 7.2 equals x. All right. So to approach a problem using the triangle proportionality theorem, I have to have these parallel line segments. One of them is inside the big triangle. And I have to take that inside line segment and follow it over to the other walls of the triangle. And I have to know the distance above and below, above and below. Let's look at number 2. Number 2, I have these little arrows again. And those little arrows mean what? Means parallel. So I have these 2 parallel lines, just like in the last problem. We're going to look at this inside parallel line right here. We're going to follow it to the other 2 walls of the triangle. So right here, it intersects the other wall of the triangle. Do I know the pieces above and below that? Yes. So far, we're just like our last problem. And then I go to the other wall where we hit the other side of the triangle. Do I know both sides of that? No. We don't know this. So we have to set it up a different way. Instead of being able to do my 2 fractions, yes, instead of being able to do my 2 fractions with those 2 split sides, I'm going to have to look at this as a full big triangle and a small triangle. So I'm going to do big triangle over small triangle equals big triangle over small triangle. Here's my small triangle. How many sides on the small triangle do we know? We know 2. I know a side that's 10, and I know a side that's 12. Those have to be my denominators, because my small triangle is going to go in the bottom. Now, before we get too deep into this problem, you could do small over big, small over big. It doesn't have to be big on top, but your 2 fractions have to be set up the same way. So if I do big triangle on top in one, I have to do big triangle on top in the other. All right, so let's look at these 2 fractions here. One denominator is 10. One denominator is 12. Up in my numerator, I need my big triangle pieces. What do I have that corresponds to my parallel side here? My 12. 26 minus x. So these 2 have to make a fraction together. 26 minus x has to be on top of the 12. Is this 2x plus 6 a whole side of the big triangle? No. 2x plus 6 only goes from here to right here. I need the whole side so that I have my big triangle. How will I get the whole side of that big triangle? What'd you say? Add. Let's add those together. So I'm going to do 10 plus 2x plus 6 Now I've got some like terms in there. I have a 10 and a 6 that are like terms. So what do I get when I add these two together? 16. So I would have 2x plus 16 here. And that has to make a fraction with 10 on bottom. All right. Do you guys understand why we couldn't set it up the same way we did the last one? I don't even want to get into how we set this one up. Do you just understand why we couldn't do it the same way we did the last one? Yep, I was missing these pieces here. So then I have to do it the way we've been doing the problems like on the last homework, where I have to match up corresponding parts. So parallel side matched to parallel side. This side of the triangle, small triangle, had to match to this side of the big triangle. So I had to add those pieces together, and those had to make a fraction together. All right. How many places do we see x? 2 spots. Part of one fraction or part of both fractions? Part of both fractions. So we're going to have to get rid of both fractions here. We have to get rid of both denominators. We'll do it one at a time. Does it matter which denominator we get rid of first? Nope. Do you want to get rid of the 10 first or the 12 first? 10. That's the first thing I saw. It does not matter if you want to do it a different way. You can. So I'm going to multiply both sides by 10. The 10 cancels out over on the left. So on the left, I just have 2x plus 16. Over on the right, that 10 has to distribute to both parts of my numerator here. So I have 10 times 26, which gives us 260, minus what? Minus 10x over 12. Now we'll get rid of our denominator of 12. So I'm going to multiply both sides by 12. Make sure you're putting parentheses around everybody. Super important that you put those parentheses around everybody. 12 distributes to both the 2x and to the 16. What is 12 times 2x? 24x. Plus, what's 12 times 16? 192. So 24x plus 192 equals 260 minus 10x. Then I'm going to get my x's to the same side, so I'm going to add 10x to both sides. What is 24x plus 10x? 34x plus 192 equals 260. Then I'm going to minus 192 from both sides. And I get 34x equals what? 68. Finally, we're going to divide both sides by 34. What do we get for x? X is 2. All right. So when I see these parallel lines, one inside the triangle, one side of the triangle, and then one inside. When I see those parallel lines, first I go look to where that inside parallel line touches my big triangle. If I know both sides of where it's being split, then I can set it up just this over this, this over this. If I don't know that, then I have to do big triangle over small triangle. Big triangle over small triangle. And I'm going to have to end up adding some pieces together most likely. All right. Let's flip the page over and look at number 2, part B. And we're going to decide which way we can set this problem up. All right, I got my parallel lines again. Parallel line here, parallel line here. Look at that center parallel line. Up here, I know both sides. I have 7 and 11x minus 12. On the other wall of the triangle, do we have both pieces? No, right here, I don't have these pieces. So how do I have to set this up? Yes, big over small, big over small. Would you head up for me, dear? Let's get your notes out, please. So big triangle over small triangle is equal to big triangle over small triangle. All right, so here's my small triangle. These are my denominators. What will my denominators be? One of them will be a 3, because that's coming from my small triangle. What else comes from the small triangle? 11x minus 12. So those are my 2 denominators. Those are my small triangle pieces. So one denominator is going to be a 3. The other denominator is 11x minus 12. So far, so good? All right, now we need big triangle stuff. What's a side that we know on the big triangle? We know 8. I know this side right here. Does that correspond to 3 on the little triangle, or does that correspond to 11x minus 12? Corresponds to the 3. So these have to make a fraction together. So 8 is going to go up on top of my fraction that has 3 as the denominator. For my other numerator, remember, I need the big triangle, right? Do I have this whole side? No. What would I need to do to get that whole big side? Add. Let's do 7 plus 11x minus 12. Do I have any like terms to combine? 7, and it's a minus 12. It's a negative 12. So I do 7 minus 12 to combine those. What is 7 minus 12? Close. Negative 5. You were just one off. That's okay. So I have 11x minus 5. That right there makes a fraction with this, because those are corresponding. So 11x minus 5 is my other numerator. So far, so good? All right. We need to get rid of our denominators. Doesn't matter which one I get rid of first. Do you want to get rid of the 3 or the 11x minus 2? 3 sounds good. That's the first one I heard, so I'm going to multiply both sides by 3. Cancels my denominator on the left. So on the left, the only thing I have remaining is an 8. On the right, what do I have to remember to do with that 3? Distribute. Where does it distribute to? Just to the top. 3 gets multiplied to the 11x. 3 gets multiplied to the minus 5. What is 11x times 3? 33x. Minus what? Minus 15 over 11x minus 12. Now we have to get rid of that 11x minus 12, so we're going to multiply both sides by our other denominator. 11x minus 12, and over here we multiply 11x minus 12. Cancels out on the right. On the left, we have to take the 8 and distribute it to both pieces. So I have 8 times 11x. I know that's going to give me 88x. Minus, what is 8 times negative 12? Negative 96. So 88x minus 96 equals 33x minus 15. Then we get our x's to the same side. Do you need another notes packet? Okay. We're going to subtract 33x from both sides. What is 88 minus 33? 55. So 55x minus 96 equals negative 15. What should we do now? Add 96 to both sides, yes. Page right here. What is negative 15 plus 96? 81. So 55x equals 81. Then we divide both sides by 55. And this one doesn't come out so pretty. Comes out to be about what? 1.47, and then that third number on there is like a 2. But then what's the number after the 2? 6, right? Oh, 7. It's going to round my 2 up if I round my number. So 1.473. If you write 1.472, I would accept that. That'd be perfectly fine. Okay. Yes. Thousandths place is usually my preference. If the test directions say something different, say something less than that, you can go with less than that. I'm never going to ask for more than that, though. That's a great question. Right, let's look at number 3. Given the triangles are similar, find x, then find the length of RS. They forgot to draw in the little arrows for parallel, but these two are parallel. So I have that inside parallel line. I'm going to follow that over to the other 2 walls of my triangle, the 2 that it touches. It touches at J and it touches at K. Do I have both sides of point K? Do I know how big those segments are on either side? Yes. Okay, so then let's go up and look at J. Do I know the size of the segments on either side of J? Kind of. I've got the 20, right? And I know how big the whole big long side is, so can I find that other little piece? What would I do to find that other little piece? Subtract. What should I subtract? 44 minus 20, and that gives us what? 24. So do I know both sides there? Yes. So I can set this up like we did number 1. So when we did number 1, I took these 2 and made a fraction. So 23 over 3x plus 5. Equals, and then I do the same thing with these 2 pieces over here. With the 20 and the 24, we're going to make a fraction. Which one should go on top? So I have to make sure I set this up right. Which one did we put on top over here? 23. So if 23 is on the top, and I have to make sure that my other fraction is corresponding, what should go on top of my other fraction? 20. So we'll put 20 in our numerator and 24 in our denominator. The 3x plus 5 and the 24 both came from the little triangle, and these two pieces came from these leftover little stubby pieces. So those are corresponding. All right, let's do some multiplying. Let's multiply both sides by 3x plus 5. All right, so it's going to cancel out over on the left. So on the left side, the only thing I have remaining is 23. Over on the right-hand side, my numerator of 20 has to distribute to both the 3x and to the 5. What is 20 times 3x? 60x. Plus, what is 20 times 5? 100 over 24. Now we multiply by our denominator of 24. Cancels out my denominator on the right. What is 24 times 23? 5, how much? 552, thank you. 552 equals 60x plus 100. Then I'm going to subtract 100 from both sides. So I have 452 equals 60x. Divide both sides by 60. And what do we get? 7.53, and only the 3 is repeating, so the bar only goes over the 3. 7.53 repeating. Is that the end? Is that everything we were supposed to find? No, it said to find x, which we did. We did that part now. But then we also need to find what? The length of RS. So I want this right here. RS equals, what do I need to do to these pieces if I want the length from here all the way over to here? Add them. 23 plus 3x plus 5. So RS equals 23 plus 3 times 7.53 repeating. When you go to put that into your calculator, don't just put 53. Put a couple of 3s after it. So 7.5333. Because that 3 is repeating. What do you get? 50.59 repeating, so about 50.6. And if we hadn't rounded this, then it would be exactly 50.6. What'd you say? But you're adding it to 23. Did you forget that piece? Got it. All right. That's all we're going to cover for today. The homework that you guys picked up on your way in the door is due on Friday this week. Homework is due on Friday.